About translations, which is simply taking a figure, moving it left, right, up, or down. We talked about reflections, where we reflected over a line. We talked about the combination of those two. But when we moved or changed figures so far in this chapter, what's happened to the figure? Did it change its shape? No? Did it change its size? Just changes the position, right? That's it. Okay? It was in a new location. Sometimes it may be facing a different direction if we reflected it. If we translated it, maybe we just moved it on top of each other. We real quickly talked about rotations on Friday. And so sometimes it could be rotated just a little bit, but none of those three things changed the size of my figure. Today that's going to be different. Today we're going to take a triangle or whatever figure that we have, and we're going to do what we call a dilation to it. And so a dilation is going to be making a figure either larger or smaller. It's still going to be a triangle if we start with a triangle, but it's just going to be a bigger triangle or a smaller triangle based on what we had. All right, so today is all about what we call a dilation. A dilation is a transformation which takes a figure and enlarges it or reduces it with respect to a fixed point called the center of dilation and a scale factor. And the best example of this, we talked about maybe a little bit last week, but if I take a photograph and I have just a regular photograph, like if you were to print some out at a photo shop somewhere, Walgreens or Walmart or something like that, and get a bunch of pictures made, then they're going to usually make them in the normal size, right? But then sometimes if you take like a family photo or whatever, or like you look at like the banners of some of the athletes, and when they're seniors, they have their senior banners, they're going to blow it up, right? And they're going to make it really big and put it against the fence or along the wall or something like that, or put it on the wall in your house if it's a family photo. So it's the same picture, but if I don't enlarge the whole thing, then it looks really distorted. And then you got people in your family that their faces are going to be all squishy or spread out, and it's not going to look very good, right? Nobody wants that. So you got to take everything in that picture and you got to dilate it or enlarge it the same increment all the way through. Same thing would be if I took that same picture and I wanted to put a wallet in my wallet, then I would make it really small. So I'd have a picture, the same picture, but it would be somewhere I could put in a little bit smaller situation. Okay, so we are going to look at what we call those two here in just a second. The scale factor K is a positive number such that K equals C to P prime over C to P. And so when I see that prime notation, that means we're going to put the new over the original. Okay, and we'll look at some examples of how we write that here in a little bit, but you're always going to put the new over the original. And the new might be smaller, the new might be bigger, but that'll give me the right scale factor then. When I have a dilation, size is going to be different, right? It's going to be smaller, it's going to be larger, but angle measures are still going to be the same. If I were to look at a triangle, and let's say that I have an equilateral triangle. When I redraw this, I still have an equilateral triangle, so that means all my angle measures are still 60, right? If I tell you that this one was 2 inches long and this one is 4 inches long, then my scale factor would be 4 over 2, which would be 2. Right? So the figure is bigger, but my angle measures did not change in that particular figure. Okay, so that is where we got to be careful about what is preserved versus what is not preserved. Side length is not preserved on an enlargement or a dilation. So if my scale factor is bigger than 1, then we call that an enlargement. Maybe I'm going to double the size or triple the size. Then that makes it that much bigger. So we're enlarging it. If I wanted the same picture, but I wanted something that was half the size or a fourth of the size, then my K value, my scale factor, is going to be somewhere between 0 and 1. We're not going to get into the negatives. We're not going to have a negative scale factor. That doesn't make sense. We call this a reduction. We're reducing the size of it. So an enlargement versus a reduction. And those are two completely different things. Okay? So this might be K equals 1/2 because it's half the size, whereas this one might be K equals 2 because it's twice the size. Same number, right? 2, but are we dividing it by 2 or are we multiplying it by 2 is quite a bit different. So here's how we come up with the scale factor. Up here, we said C to P prime over C to P. So C is the point where I'm doing the dilation from. We always want the new figure on top. Okay, so the new figure or the new length is going to go on top. So if I go from C to P prime, how far or how long is that length? 12. Yeah. And if I go C to P is the original length, which is 8. So we would go 12 over 8, and that would reduce to be 3 over 2. So your scale factor will not always be a nice whole number like 2 or 3, okay? It might be a fraction. Okay, but this is an enlargement, right? My new paper clip, or here, not paper clip, but pen, is bigger, okay? And it's 1.5 times bigger or 3/2 bigger than the original. This is my original one, because this is the P. This is my new one, and it's larger. So because this number is bigger than 1, that makes it larger. Okay, over here, the formula is the same every time. But if I look at the paper clip here versus the new paper clip, this one is considerably smaller, right? And it's the new one. So if we wanted to compare the size of these two, C to P prime is 18. C to P is 30. And then we always reduce it, okay? Don't put it in your calculator and just take 18 divided by 30 because we don't want to write it as a fraction, or I mean as a decimal. We want to write it as a fraction. So what goes into both 18 and 30? Okay, 2. Anything bigger? 6. Okay, anything bigger?
9.
Not quite. 9 goes into 18, but not 30. 6 would be it, yep, because 2 goes in there, 3 goes in there. 6 is the biggest thing that we want. So we want to take 6 out. So if I take 6 out of both of these, 6 goes into 18 3 times, 6 goes into 30 5 times. If I had taken 2 out, then it wouldn't be completely reduced. If I had taken 3 out, it wouldn't be completely reduced. So make sure you take the largest number out, and we say here that our scale factor is 3/5. Your scale factor may just be a fraction, and that's okay. This one here is an enlargement because it's bigger than 1, which means this one here is a reduction. Okay, the only thing different about the one down here is that it is not, there's no picture provided, okay? But it's really okay because it gives me exactly the information that I need or want. You just have to remember that the prime, the new number, has to go on top. C to P prime is the new number. Just like P prime is always the new figure, we always want the new one on top, which is 3. And the original is 12. And then we reduce it to be 1/4. So is this a reduction or is this an enlargement? It's a reduction. How do we know? It's less than 1. Okay. 1/4 is less than 1. If it's bigger than 1, it's an enlargement. If If you don't know what the decimal is for 1/4, or if it's bigger than 1 or less than 1, just divide it, right? If it's 1 point something, or if it's a number bigger than 1, it would be an enlargement. If it starts with like 0 point something, then it's a reduction. All right, so now we're going to actually do some dilations here, okay? So as we look at these dilations, we're going to do some that are we're going to do some that are enlargements, some that are reductions. So we're going to do a little bit of both. Okay, this one has a scale factor of 2. So we're going to say k equals 2. If we write out a rule for this, based on what it's saying up here, is we're going to apply that change, that scale factor, to every number that we're doing it to. So if I have an ordered pair, I'm doing it to both x and I'm doing it to y. And so that's why it says whatever the scale factor k is, we're going to multiply it by x and we're going to multiply it by y. And that's going to be our prime notation. So when I write out my rule here, just like last week when we wrote our translation rule, this week when we do dilations, we're going to just multiply it. Instead of adding or subtracting it to x and y, we're going to multiply it to x and y. Okay, and kind of what I like to do here is A, B, and C. I'm going to rewrite them down here, and I'm going to say A is at 2, 1. B is at 4, 1. C is at 4, negative 1. And then we have A prime, B prime, C prime. Before I ever graph these, I think we need to come up with what our ordered pairs are going to be. So we're going to multiply both numbers by 2, all the way down, everything. So 2, 1 is going to become 4, 2. 4, 1 becomes 8, 2. 4, negative 1 becomes 8, negative 2. Okay, so let's graph both of these and see what the difference, and see what it looks like here. Okay, there's my original. This is A, B, and C. Okay, my new one is at 4, 2. Eight, 2. And 8, negative 2. And this would be A prime, B prime, and C prime. Okay, a couple of things that I want you to notice here. First of all, the sides that match up are parallel to one another. Notice how AC and A prime C prime are parallel. They're not going to cross one another. Okay, same thing for AB and A prime B prime and BC. All of the sides are parallel. Now, if I look at the length, watch what happens to the length. What's the length of AB? How long is AB? 2, okay? If I look up here, A prime, B prime is 1, 2, 3, 4 long, okay? So the length went from 2 to 4. So how much longer is it? 2 times bigger, okay? And I could do that for all 3 sides. Now, the fact that it's horizontal makes it easier. I can't really do that as easy for this side here because I'd have to do the distance formula, and I'm not going to make you do the distance formula here, right? But it's 2 times bigger. And that's an easy way to tell that if my side's 2 times bigger and I do it to everything, then everything should be 2 times bigger when I do that, except for the angles. Okay? Any questions on that? Everybody good there? All right, let's go down here. L, K, M, and n. I thought I had enough room there. Let's just do it down below. My rule here, xy matches with 1/3 x, 1/3 y. Okay, now I'm going to show you a trick here. And this looks like it's going to be really hard because, oh my gosh, we've got a fraction. We got to multiply by a fraction, really, right? So we think it's going to be really hard, but it's not as bad as what you think. And most of the time, we're going to give you numbers that are really easy to work with if we have a fraction like that. And I'll show you why. May not always be that case, but we'll try to be pretty nice to you. So we're going to become L prime, K prime, M prime, N prime. We have 4 new points that we got to come up with. And the scale factor here is 1/3, okay?
I think you have L and K mixed up.
Oh, did I? Oh, sure enough. Thank you. Okay, so what we're going to do is same as we did up above. Now, the one up above was easy because we're doing a scale factor of 2. So all I got to do is double everything, right? Well, here we've got a scale factor of 1/3. And I told you we were going to give you really easy numbers. So if I were to multiply by 1/3, what is multiplying by 1/3 the same as?
Times 3.
Nope.
Divided by 3.
Dividing by 3. Yeah, dividing by 3. Okay? So you have a choice. You can either put it in the calculator and take 6 times 1/3, or you can simply just divide by 3. If you were going to multiply by 1/3, most of you would probably say, I need a calculator. But we really don't need a calculator here. 0 divided by 3 is still 0. 6 divided by 3 is 2. So my new ordered pair is going to be 0, 2. Okay, on this one here, I'm going to divide by 3. Negative 3 divided by 3 would be negative 1. 6 divided by 3 is 2. Okay, I'm not saying that you can't use your calculator, but do we really need our calculator? Hope not, right? Hopefully we can do 6 divided by 3 and not worry about a calculator. But if you want to check it, you can always check it. I kind of cut off M. M was at 3. Okay, so both of these divided by 3. 3 divided by 3 would be 1, 1. And then N prime would be negative 1, negative 1. Okay, and then it is a little tedious because then we got to graph it. And not only do we got to graph the original, but then we got to graph the new one as well. Logan, you getting all this down? Okay, so now 0, 6. Negative 3, 6. 3, 3. Negative 3, negative 3. Okay, there's our first figure. Our second figure, 0, 2, negative 1, 2, 1, 1, negative 1, negative 1. Okay, it's quite a bit smaller. Now watch what happens here. If I went from K to N, how long is it to go from K to N? How long is k in? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 units long, right? If I went over here, this is k prime, l prime, m prime, n prime. How long is k prime n prime? 3. So how much shorter or smaller is the new one than the original one? Divide by 3. 9 divided by 3 gets me to 3. So that's kind of a way to check to see, does my new figure match, right? Does it fit what we're talking about? It's a third of the size or 3 times smaller, however you want to say it. That means the same thing. A third of the size means it's 3 times smaller, okay? All right. I think for right now we'll skip this one. Maybe we'll come back to this one tomorrow, but it's very similar to the one that we did up above here, except we're multiplying it by 4. All that means is it's going to be quite a bit bigger, okay? It's going to be quite a bit larger if we're multiplying it by 4. Okay. We said at the beginning that we don't want scale factors to be negative numbers, but what happens if scale factor is a negative number? Then what that means is the whole figure is going to be rotated 180 degrees. So it's going to take it and it's going to flip it upside down. And it's also going to dilate it at the same time. So there's 2 things that are taking place. We're rotating it and we're either enlarging it or reducing it. The center of dilation that we're always going to use is 0, 0, okay? When we do on a coordinate plane. We're not going to go about some other point. So we're always comparing it to 0, 0. So if a figure starts up here, when I do a 180 degree rotation, it's going to end up in the opposite quadrant. If it started up here, it's going to end up down here. So it's always going to end up catty corner from where it started at. So look what happened here. This is my pre-image. This is my original. If I blow it up, I got it bigger. If I rotate it 180 degrees, now the new figure is going to be all the way down here. So we're going to make it larger or smaller, and we're going to rotate it. Okay? And so that's what all this box is saying. If we have negative numbers with our dilation, it'll rotate it. It could still be a dilation that is bigger or smaller than 1. So let's look at an example here. F, G, H. Okay, my rule here is we're going to take every number and we're going to multiply it by negative 1/2. All that means is we're going to change the sign and we're dividing by 2. So if I did F prime, G prime, H prime, okay, there's my original figure. 2 things are happening to this figure. Because I'm multiplying it by a negative 1/2. It's going to be smaller and it's going to be rotated. So it's going to sit a little bit different direction. Now when I rotate it, it's going to rotate this direction and it's going to sit a little bit differently. So let's see what it looks like if I rotate it 180 degrees. So first up, let's figure out what our new ordered pairs are going to be. We're going to divide by 2 and change the signs. So let's look at F first of all. Dividing by 2. First of all, these are both negative, so they're both going to become positive. And 4 divided by 2 would become 2, and 2 divided by 2 would become 1. So it's now going to be at 2, 1. Okay, negative 2, 4. 2 divided by 2 is 1, and it becomes positive, because it's going to be the opposite. 4 divided by 2 would be 2, and it's going to become negative. And then h. We're going to divide by 2 and change the sign. So it's going to become 1, 1. So we would label that F prime, H prime, G prime. Look at the figure now, okay? This one here is HF. This one here is originally, or H prime, F prime over here. This is originally 2 units long. This is only 1 unit long. So it's half the size of the original, right? Which is what we were saying, half the size. The other thing that's been changed is, look at where this bottom side is right now, and now it's my top side, right? It's been taken and it's been rotated. So now the bottom's the top and the top's the bottom, basically. And that would be my new figure. So does it look right, okay? And that's a really important thing, because when I look at it and say, does it look right, then what we want to determine is, if it doesn't, that means I've plotted something wrong. And that's usually the biggest mistake that gets made on these, is it's really easy to plot 1 point wrong, and that throws off the entire figure, if just 1 point is wrong. And that was probably the biggest mistake that was made on the quiz last week, is not necessarily doing the math wrong on the translations or the reflections. It was plotting a point in the wrong spot and gives me a completely different figure, okay? So you got to be kind of tedious about what you're doing when you do these. All right. Let's see here. I think the last page we will save for tomorrow. So, and that way you guys can work on your assignment a little bit today. So let's do this last one here together. This is P, Q, R. Okay, my rule here is we're going to take all numbers and multiply it by -2. Let's plot the original one first. It's kind of up to you how you want to do all of that. You can wait and do all the plotting after you have the numbers. You can do the first one first and then come up with all the numbers, however you want to do it. Okay, but that's what our first original figure looks like. Okay, my new one, we're going to multiply everything by -2. This one's a little bit easier. Okay, everything gets multiplied by -2. So we're going to double it, and we're going to change the sign. So 1, 2 becomes -2, -4. Q becomes -6, -2. R becomes -2. And then notice this one becomes +6. It was negative to begin with, and now it becomes positive. So when you look at your X and Y's, they should always have the opposite sign on it when we have that negative on there. And so -2, 6. Okay, 2 things that we should notice here. Is my new figure bigger? Yeah, okay, and if we wanted to see if it really is 2 times bigger, look at P to R. 1, 2, 3, 4, 5. Over here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one over here had a length of 5. This one has a length of 10. 2 times bigger. And is the figure sitting in a different direction? Yeah. Okay. R was facing this way. Now R, we've taken it, or Q is sitting this way. Now Q is facing the other direction. We've taken that figure and we've rotated it a complete 180 degrees. Okay. For your assignment today, then you should be able to do the first 7 questions, okay? Just the front side of 4, 5. And then tomorrow we'll talk about the rest and let you finish it up, okay? So try to get through as much as you can on the first 7 today. If you don't get it done today, you can finish it up tomorrow, but for the rest of the hour, you can work on those first 7 questions. That whole packet will be due on Friday, but we've already graded the first 2 days of it, so it'll really just be the last couple pages.